My name is Iric. This is my prototype proposal for ME 2900. My prototype was a two-wheeled self-balancing robot. So this robot would balance itself autonomously. And the way that I do that is I use a PID controller. So PID stands for Proportional Integral Derivative Controller. And in a simplified version of what's going on is I have a set point. So in this case, it's when the chassis is parallel to the ground, and between the set point, I create a current angle. So depending on which direction it's tipping, it'll create an error curve between the two. And then since I'm looping it continuously using the Arduino, it'll essentially be creating a curve, and that's the proportional term, is creating that error curve. The integral term is the area under the curve, so it's integrating. And that kind of tells the controller how much error needs to be fixed. And then the last term is the derivative term, so it takes the current slope of my error curve and tells it how quickly it needs to be fixed. So that's a simplified version. So I create a P, an I, and a D term with all of those. And with those terms, I have constants for them, which I model with the potentiometers. And these are to help adjust for the inherent errors that come with the gyroscope that I use to calculate the current angle. Gyros by design tend to drift over time, and so I use the constants and I can play around with them dynamically to try to get an ideal situation. And so once I've multiplied each term by its respective constant, I sum those as a correction term and output them to my motors, so it knows which ways to go. So now I'll demonstrate. Since I'm not using a battery pack, I have to stay plugged in. The weight of the cord has some effect, but I try to reduce it by just holding it. So the LED in the middle is my balance LED. So once the robot has declared that it's met its set point, basically reduced the area under that curve, it will light up. And then if it needs to correct, it'll turn off. So as you can see, I gave it a little tilt so it knows that its current angle is different. So now it's beginning to correct itself until it comes to the blue LED turns back on and signify that it's balanced. So I'll turn all of the control constants, the tunings, to 0. So now that the PID loop thinks that there's no error being generated, so it doesn't know how to correct itself because it thinks it's already corrected itself. So then I'll start to add in the constants back in so you can see how they affect the movement. So I'll just create my error curve, but since I'm just creating the error curve, the PID loop doesn't know what to do with that because I only have my proportional term. So then I'll add my integral. So now you can see that the robot is attempting to correct its error, but it doesn't know how quickly to correct its error. So it goes at its own set time, which is just the generic timing of the Arduino in the void loop. So then I'll add the derivative term, and now the PID loop knows how fast it needs to correct itself, so you can see it's taking shorter dips in between to try to correct itself back to the set point. So I'll try to readjust my terms and then alleviate some of the weight of the cord that's affecting the gyro. So you can see that the robot will return to its balance point and within a set point. So at the moment I have between 5 and -5 degrees. So my name is Iric and this is my self-balancing robot.